Hello guys, welcome back to yet another session on the basic concepts of chemistry. In today's session, we will learn about the Avogadro's number. Then we will move ahead with certain formulas which can be used for the calculations at the atomic and molecular level as well as for the substance level, like for calculation of volumes or the number of solutes or the number of moles, etc. So let's get started. First of all, Avogadro's constant, I'll give you all a brief or the basic idea. It is the constant, and the value for Avogadro's constant is 6.022 into 10 raised to 23. Let's move ahead. Mole concept and molecular mass. As we all know that mole, or can be written as MOL, is the SI unit for the amount of a substance. 1 mole contains exactly 6.022140076 into 10 raised to 23 entities, that is atoms, molecules or any other particles, and this was given to us by Avogadro. Avogadro said that 1 mole contains exactly 6.022 into 10 raised to 23 atoms or molecules or any other particles. Hence, this number was called as Avogadro's number or Avogadro's constant, and it is denoted by Na. It needs to be the number, the value 6.022 into 10 raised to 23 has to be kept in mind. Now, since the atoms, molecules, and other particles constitute 1 mole of a particular substance, we know that most of the atoms might be containing 1 mole of a particular substance. So we say that 1 mole of a particular atom is equal to 6.022 into 10 raised to 23 atoms. Or for example, 1 mole of water molecule is equal to 6.022 into 10 raised to 23 molecules. We can say so, and this was given to us by Avogadro. Now let's learn about the molar mass. The mass of 1 mole of a substance in grams is called as the molar mass. So if 1 mole of a substance is written as grams, if the mass of 1 mole of a substance is written in grams, then it can be called as the molar mass. And this molar mass is equal to the atomic, molecular or formula mass in U. U here is unified mass, as we have already discussed earlier. Now let's go on to the checking of the purity of a substance. This method or this formula is applicable for elements, that is at the elemental level in a compound. For example, while calculating the mass percent of an element, the formula given here is mass percent of an element is equal to mass of the element in a compound divided by molar mass of the compound multiplied by 100. We shall look into the example to solve the mass percent or to find out the mass percent of a particular element or to check the purity of a substance. You need to keep in mind this formula. Let's consider this problem. Now we need to calculate the mass of particular elements, that is carbon, hydrogen and oxygen in this example. And the molecule is ethanol. We know the formula for ethane. Ethane is C2H6. But here we bring alcoholic group. So it is C2H5OH. Since there is OH group, we use OL at the end. We have earlier seen that molar mass of ethanol or molar mass specifically of any compound can be calculated from its individual atomic masses. So here there are 2 carbon atoms. Hence we multiply 2 into the atomic mass of carbon atom. There are altogether 6 hydrogen atoms, 5 and 1 from the alcoholic group. So 6 multiplied by the atomic mass of the hydrogen atom, which is 1.008, and only one oxygen atom. And we know that mass of oxygen atom is 16 grams. So if we solve this entire mathematical equation, then we get the answer as 46.068 grams. Now let's go on to the main part, that is calculation of mass percent of a particular element. So for this, first we'll go on for carbon. Mass percent of carbon will be equal to 24.02 grams of that particular element, that is 2 multiplied by 12.01 is 24.02 grams upon the whole molar mass of that particular compound or that particular entity. By calculation, we will get the answer as 52.14. Moving on to hydrogen. Mass percent of hydrogen is calculated as follows. In the numerator, we'll have 6.048 grams, and in the denominator, we'll have 46.068 grams. So, by calculation, the answer is 13.13%. Here we take 6.048 grams for hydrogen, mainly because there are 6 hydrogen atoms and individual atomic mass of hydrogen is 1.008. Moving on to mass percent of oxygen. We have seen that there is only one oxygen atom over here. There is only one oxygen atom. Hence, we take it as 16 grams divided by the whole mass, molar mass, and the answer is 34.73%. Based on this, we can calculate the percent purity. Moving on to the mass percent. Now we are looking at the solution, that is states of matter, or that is solid, liquid or gas. Now these are calculations based on these states of matter. Now here for calculation of mass percent, it will be based on the solid particles and the liquid particles. For example, mass percent, the formula is mass of the solute divided by mass of the solution multiplied by 100. This is the formula for mass percent. Similarly, there is another formula for molality. This word has to be pronounced properly. This is molality. There is another word which has R over here instead of L, and that is molarity. And the definition for molarity is different and molality is different. Here, molality, that is small m. The symbol is small m and its formula is number of moles of the solute divided by mass of the solvent in kg. This has to be kept in mind. So multiplied by 100. So molality is number of moles of the solute divided by mass of the solvent in kg multiplied by 100. Moving on to mole fraction. Now let's consider mole fraction. If there is a substance A, for example, we consider two substances A and B, and the number of moles in A and B are denoted as Na and Nb respectively, then the mole fraction of A, that is number of moles in A, fraction of A, is given as number of moles of A and A divided by the number of moles of the solution, that is Na plus Nb. By using this formula, we'll get the mole fraction of A, specifically A. And to find the mole fraction of B, instead of writing A over here, we will write B, mole fraction of B, and in the numerator it will be number of moles of B, and denominator it will be the same number of moles of the solution. Here is the exact formula for mole fraction of B. And lastly, we have come the most important formula, that is molarity. Molarity is defined as the number of moles of the solute per liter of the solution. This has to be in liter. So the formula for molarity is equal to number of moles of the solute upon volume of the solution in liters. This is the final formula, and we will be considering all these formulas in our calculations. That's it for today. Thank you very much for patient hearing. If you have any queries or any suggestions related to this topic, you are free to type them up in the comment box. Thank you.